So now we're looking at the rational zero theorem, which, if you remember, that means that the possible rational zeros of a polynomial are p over q, where, let me write that down, p over q, where p is a factor of the constant, and q is a factor of the leading coefficient. So in this case, we're looking at the factors of 1, because that's our, and it goes without saying that we want to check and make sure that it's in standard form. In other words, descending order of the exponents on x, to make sure we have the correct leading term and the correct constant. So we're looking at the factors of 1, or factor of 1, over the factors of 1. So in other words, our possible p's, are plus or minus 1, because that's the only factors of 1, and our possible q's are plus or minus 1. So if we look at our possible p over q, it equals plus or minus, well, in this case it's just 1 over 1, so it's just plus or minus 1. So our possible rational zeros are 1 and negative 1. So to determine what the rational zeros are, well, what are zeros? Zeros are where the function is equal to 0, where y equals 0, f of x equals 0. So to determine what the rational zeros actually are, we take all of our possibilities, which in this case are just 1 and negative 1, and we substitute those in for x, and if it yields a 0, then that means it's a rational zero. That means it's one of the zeros. So we'll start with x equals negative 1. So f of negative 1 equals negative 1 cubed minus 5 times negative 1 squared plus 2 times negative 1 plus 1, which equals negative 1 cubed is negative 1 minus negative 1 squared is just 1, so this is just going to be minus 5. And then 2 times negative 1 is minus 2 plus 1. So that ends up being negative 1 minus 5 is negative 6, minus 2 is negative 8, plus 1 equals negative 7. So negative 1 is not a rational zero for our given function. So we'll look at our other possible rational zero of 1. So f of 1 equals 1 cubed minus 5 times 1 squared plus 2 times 1 plus 1. 1 cubed is just 1. 1 squared is just 1, so this would be minus 5. 2 times 1 is plus 2, and then plus 1. So that ends up equaling 1 minus 5 is negative 4, plus 2 is negative 2, plus 1 equals negative 1. So neither one of these yields a 0 for our function, which means there is no rational zero for this function. Which happens if you graph f of x equals x cubed minus 5x squared plus 2x plus 1, you'd see that it never crosses the x-axis, which means there's never going to be a real zero, so there's not going to be a rational zero. So in this case, there are no rational zeros. So any zeros for this function would be in the complex number system.